The position and nature of the image formed by a spherical mirror can be determined by drawing a ray diagram. Click the ray button to observe the ray diagram for a concave mirror. Three rays can be drawn, of which two are sufficient to locate the position of the image. The three rays are drawn from the same point O of the object. The position of the image is where the rays intersect after reflection by the mirror. The focal length of the concave mirror is 10 centimeters, and the distance of the object from the mirror is 30 centimeters. Use the grid shown to answer the following questions. What is the distance of the image from the concave mirror? Answer: 15 centimeters. What are the characteristics of the image? Answer: the image is real, inverted and smaller than the object. Exercise. The focal length f of a concave mirror is 10 centimeters. On pieces of graph paper, draw ray diagrams to show the formation of images by the concave mirror for object distances of 30 centimeters, 20 centimeters and 7.5 centimeters. To check your answer, click on the object and drag it to vary the object distance. Click the next button and choose the characteristics of the image for the different object distances. Click the ray button to observe how the ray diagram for a concave mirror is drawn. The ray diagram for a convex mirror can be drawn using three rays, of which two are sufficient to locate the position of the image. The three rays are drawn from the same point O of the object. The position of the image is where the rays seem to intersect after reflection by the mirror. Now click and drag the object to vary the distance of the object from the convex mirror. What are the characteristics of the image formed by the convex mirror? Answer: for all positions of the object, the image formed by the convex mirror is virtual, upright and diminished. Summary. Two of the following three rays are sufficient to determine the position of the image formed by a spherical mirror. A. For the concave mirror. 1. A ray parallel to the principal axis is reflected from the focal point. 2. A ray passing through the focal point is reflected parallel to the principal axis. 3. A ray that passes through the center of curvature is reflected back along the same path. B. For the convex mirror. 1. A ray that is parallel to the principal axis is reflected from the focal point. 2. A ray directed towards the focal point is reflected to the principal axis. 3. A ray directed towards the center of curvature is reflected back along the same path. The characteristics of the image formed by a concave mirror depend on the distance of the object from the mirror. The image formed by a concave mirror depends on the position of the object. The image formed by the convex mirror is always virtual, upright and smaller. The relationship between the object distance u, the image distance v, and the focal length f is known as the mirror equation. Click on the object and observe two rays from the point O on the object. The ray OP is reflected along PI such that the angle of reflection IPQ is equal to the angle of incidence OPQ. Click the derivation button to observe how U and V are related. The ratio of the height of the image, HI, to the height of the object, HO, is known as the linear magnification, M, of the image. Click the linear magnification button to observe the relationship between linear magnification M with the object distance U and the image distance V. Click on the object and observe how the image is formed by a convex mirror. Click the derivation button to see how U and V are related. Click the linear magnification button to see the relationship between M, U, and V. When using the mirror equation, we must be careful about the signs of the quantities U, V, and F. Sign convention is used to denote the types of object, image, and mirror. Click the sign convention button. Click the relevant buttons to learn the meaning of real and virtual image. The relationship between the image distance, V, and the object distance, U, can be investigated experimentally. An object of height, HI, equals 10.0 centimeters is initially at a distance of 60.0 centimeters from a concave mirror. Click on the object and observe the formation of the image by the concave mirror. Click and drag the object to vary its distance from the concave mirror. Note the image distance and height of the image when the object distance U is 50.0 centimeters, 45.0 centimeters, 40.0 centimeters, 35.0 centimeters, and 30.0 centimeters. Click the next button to observe the various graphs which can be used to determine the focal length f of the concave mirror. Summary. Object distance u, image distance v, and the focal length f are related by the mirror equation 1 over u plus 1 over v equals 1 over f. The real is positive sign convention. A. Object distance u is positive if the object is real, and u is negative for a virtual object. B. Image distance v is positive if the image is real, and v is negative if the image is virtual. C. The focal length f of a concave mirror is positive, and for a convex mirror is negative. Linear magnification m equals height of image over height of object equals v over u.